Okay, yeah, that would be good. Yeah, all right. Good afternoon, everyone, for the first class of week 12. So, inshallah, today what we are going to cover, we are almost going to close this chapter, the MOSFET. But this week we will finish it for sure, inshallah. So, what we are going to do today, we are going to talk about something really important in the MOSFET, or the amplifiers. We are going to characterize them. You need to know what they are really. When you make them, you sell them, hopefully. You tell your customer, it has this, 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 this. And he will swallow that, take it, give you money. Or he tell you, good luck with you, bye-bye, I'll buy something else. You understand? Good. So we have three categories of amplifiers. And they are divided based on which terminal is connected to? The ground. اللي هو common ground. Even when you discuss with somebody, you need to have also a common ground. What is it, common ground? Common ground means something that we agree with, that we can build out of it something, discussion. Somebody in the north, somebody in the south, how can they have common ground? So they will be talking حوار الصم, صح ولا لا? No one will listen to each other, صح ولا لا? But common ground, same level, boom, the voltage up and down, and we can discuss. صح ولا لا? Good. So, the first amplifier we discussed already was the, and because the source is in the common ground. The second one will be just throw another terminal to the ground, and that will be common. Very good. And the last one will be, we throw the last terminal, that is the drain, to the ground, and boom, we have common drain amplifier. That's it. See? Simple. صح ولا لا? Simple. There is no memory about that. All right. These are the divisions. This is for now. We are talking about DC. When we talk about real amplifiers, we are talking about the connections here, like they are grounded, but they need to be grounded in the AC domain. Meaning, if I put here a constant voltage here, a DC voltage in the source, for example, in the AC, all DC become grounded, will be zero. Okay? So in that case, that DC voltage that I put, for example, here, like a battery. Let's say I put a battery here. Let's say, just an example, just to show you. A battery in DC is DC, a battery. But when I convert, because I need to convert this circuit from DC to AC, we'll talk about that. So all the DC components will become short-circuited, zero. So this battery will become what? Zero. Short-circuit, and that makes the source connected to the ground. Do you understand? Something like that. So when we say a terminal is connected to the ground, we are talking about terminal connected to the ground in AC sense. بمعنى AC, not in DC sense. Do you understand? That's what it is. Very good. All right. Good. So, very good, very good, very good. So let's see what we can do in terms of characterization. There are how many? 1, 2, 3, 4 characteristics of an amplifier. 2 resistors and 2 gains. The first resistor is the input resistor. So this is a sketch of an amplifier. That amplifier has an input AC signal. That AC signal has an internal resistance, and it has a source of voltage. You know this, right? From the labs. صح ولا لا? Good. And you have the amplifier. It has input voltage, output voltage. And we have what we have, a load at the output, where we need to send our output AC signal to, okay? Very good. Excellent. So the input resistance, okay, let's see. So the input resistance is basically, I send an input current, II, input current, and I measure the input voltage. And that's it. Take the voltage, that voltage that I measure, divided by the input current, and that gives me the input resistance, or input resistance. Or called also sometimes input impedance, because the resistance is also called an impedance. Very good. The other So let's say this is check. The second resistance that is characteristic of an amplifier is called the output resistance. This one is a bit different, not too much. So the condition for the output resistance is that we put the input voltage to the ground. I ground the input, this guy, I ground it, so I make a connection with the ground now. So I don't have any input current, okay? So I ground, first of all, the input, and then, what is that? It's actually here. So I ground the input here, so it's going to be like 0, okay? I cannot do this, this is just not to confuse you. So I make this input grounded, and then I send now a current Ix into the output port or terminal of the amplifier. And then I do the same thing, I measure the output. When we say measure the output voltage here, we are measuring or calculating, the same story, okay? It's just here I'm using my brain when I calculate instead of the tool. Yes or no? That's what it is. And then I divide this voltage by this current, and then I get the output resistance. Good? Everything's easy, just we go slowly, we understand. Good. صح. The second two parameters that are very important in the characterization. Characterization, what means characterization? It means to find the character. نعرف سلوكه. Is to know how it does behave. What is character? Character, another word of character in Arabic, basically سلوك. How does it behave? يعني مثلا I give him candy and they put the candy aside. If the guy or the girl go and steal it, I know this is a stealer. So the character of this person is a stealer. This is just an example. So we know the character of that person. Same thing in here. We send a current, we measure a voltage, and we see the character of that amplifier in terms of resistance. Clear? That's how. So تشخيص. To know what is this character, what is this amplifier really. Good? Excellent. So the second two parameters are the gains, the voltage gain. The first voltage gain, we call it open circuit voltage gain. Why we call it open circuit voltage gain? Because the load resistance is taken out. So it's open circuit at the output. So RL, out. I make it super high, infinity for example, or I simply take it out. Same story, yes or no? If the resistance is too high, is there any current? No, no current. Or I take it simply out, and that's it. That's the same story. So, what is that? I'm here. Good. And for that, I know the voltage gain is the output voltage divided by the input voltage. Boom. But the output voltage at the output of the amplifier and the input voltage at the input of the amplifier. Because this voltage is different from the signal or the source voltage. It's different. This is the voltage. When we say the input voltage, it means right at the terminal of the amplifier. Not before. Right at that terminal, the input terminal. And when we say at the output, right at the output terminal. Good? Bingo. The last voltage gain is going to be, it's not the last, actually there are 5. There are 2, but these sometimes, the voltage gain and the overall voltage gain, sometimes they are equal. We'll see when they are equal, but let's start with this guy first. So the voltage gain, and I don't speak about open circuit, that means I include RL. There is RL here. So that means I have to calculate the voltage gain from the output across RL, from the input here until the output. That means V out, including RL, divided by the input at the input terminal. And that gives me what? The voltage gain without open circuit. So it's like a closed circuit, but we don't say closed circuit because we are talking about RL here. Okay? Now, the overall voltage gain, which is, let me take this out. Okay, the overall voltage gain, let me see, let me try this. Where's the mouse? Mouse is where? So what is it? Okay, good. So let me take it out. Very good. Put it here. That's better. Maybe here. Good. So the last voltage gain, which is the fifth if you want to take it that way, is called the overall voltage gain, and it includes, is actually the input, the output voltage across Rn divided by the input. I should have put actually the definition much clearer, but in the slides I will update it, so don't worry. So it's actually this voltage, the overall voltage gain, is actually, I will write it here. Maybe it's missing there. Oops, sorry about that. So go back. Let's see. So it is what it is. Okay, let me tell you right here. Okay. So it is what? V out with Rn or cross Rn divided by V signal. I will update it later on. No, it's not there. So it's the whole thing from this, or actually from here, this is the input, to here, to the load. This is called the overall voltage gain. So these are, if you want to take them individually, that's fine, okay. So we have 1, 2, 3, 4, and 5. But as I said, many times you find this, the voltage gain, is same as the overall voltage gain. At some cases, we'll see them in the next slides. Good? Clear? So these are important to know. Without them, there is no need to study the amplifier. Okay? Good. Let's start with the first amplifier. We already started, but now we are taking it more seriously. So let's see. And this is the method. We are talking about how to solve problems, how to understand it. So this is the common source amplifier, yes or no? DC, AC, blah, blah, everything's fine. Is that, Good. So this is the first circuit, the amplifier as we have it. So the first step is to convert the circuit from the DC domain to the AC domain. And we do it in step by step. So all DC voltages, they become what? 0. Because we are talking about variation. It's like we are deriving them, derivative, okay? Because we are talking about AC. So this constant voltage, DC, it becomes what? 0. This, it becomes also 0. That means there is a short circuit here. Okay? So what we will have this circuit. So we'll have an AC voltage there. It has, of course, its internal resistance, fine, is that. And then it goes to the gate of the MOSFET. The source is to the ground. The drain comes here. From the drain, I have, from this point to the ground, I have RD. And the output is taken at the drain. Boom. Okay, got it? If you have any question or you need me to repeat, ask. There's no problem with that. If you don't understand, you should ask. I always tell you that. Okay. The next step is to replace now the MOSFET with its model. See why I've told you it's chained, class, chained with other? You know which model is this? Don't read from here. Here. What's this model? We studied this model of the MOSFET, yes or no?
Yes.
So let's ask, who has revised? 1, 2, 3. Hey, small signal, yeah. Small signal model. Who did? You said no. That's fine. I respect that. No one almost. 2?
We have 2 models, bi and T.
What's that?
We have 2 models, bi model and T model.
Very good. And this one is which model?
Bi.
Very good. It's the pi model. We have at least one. Good, thank you. And we call it pi, just for the others to remember, is because it looks like a pie branched here at the output. Yes or no? The shape of the model looks like a pie. See? 2 legs and the bar between them. That's why we call it pi. Simple, you see? Electrical engineering is not supposed to be difficult. It's actually fun. No, seriously. I'm thinking to make it a comic. Comic. You know comic?
Yes.
Like, for example, Tom and Jerry or something like that. Should be like that, because it's a joke. See? They tell us this is a pi model just because the shape looks like pi. It's a joke. Good. So now we replace this by this. But how? So this is the gate, yes or no? So that's where the gate. So we have to connect the gate to this point. And the drain is there. The drain, I know this is the drain. The drain is connected to RD. So I put RD there at the drain. That's it. And the source of the MOSFET here is connected to the ground. So boom. So this is the source, right? R0 is between drain and source, and the current is going from the drain to source. Boom. Now this is the circuit that we need to analyze and characterize. This is the amplifier in the AC domain, and this is the one that we need to study to find its characteristic. Clear? Do you understand? So from here to go to that, we already studied the steps. Any question? If you don't understand this, you will not be able to solve any amplifier question. Do you understand? Clear? Any question? I'm in the video. So nobody asked. So that means it's clear. Very good. And it's simple actually. Now, let's now characterize this. So the first characteristic of an amplifier is what? Is the input resistance. Okay. I set the current here. How much current can go to the gate? Because that's the input terminal, yes or no?
0.
Very good. Very good. So the input resistance must be infinity, yes or no? Because the input current is 0. Is there any current that goes to the gate? Nothing. صح ولا لا? So our input is infinity. I didn't write because its I is equal to 0. So it's you who have to write that as a note. Because we are explaining, yes or no? So that's why you need to take note. For those who think that they can go without note, again, they cannot count only on the slides. That's why they need to take note. They have to. I can write everything, but I don't do that. Right now. So because of the input, current is 0. Now, the second characteristic is what? Is the open circuit voltage gain. And that means the output voltage, well, here, the out, divided by the input voltage, not here this one, no, this one. Yes or no? Excellent. Very good. Very. By the way, before I go further, I have to mention something. Now, why we took the DC and does it make sense that we study only the AC domain? What about the DC? Is the DC values are gone? But that's fine. What is this, the DC? Where is the voltage, DC voltage? No, we throw the DC voltage like that and study the AC amplifier. Yeah, that's fine. But what is the information about the DC? We must have some information about DC, صح ولا لا? That information is in these parameters, in R0, if you remember, and is also in GM. Why? Because R0 is equal to what? Somebody tell me. You revise, yes or no?
1 over Kn. Kn V over.
There's a simpler way. إيه صح ها. How much? We study it, صح ولا لا? Yeah?
VA over ID.
Very good, excellent. We have somebody there. Very good, excellent. Is VA the early voltage divided by ID? This is where the DC information comes in. So we did not throw the DC information away to the garbage, no. We just embedded it in the resistance R0, صح ولا لا? And also in GM. What is GM? GM is equal to what? Kn V over drive. I heard somebody there, but she didn't raise her hand. That's fine. Kn V over drive. V over drive is also a DC value because it's equal to VGS minus VT. We're talking about DCs here. See? So we did not throw the DC voltages like that. No. They are embedded in the parameters of the model. And that's what we mentioned last time. Remember? The same thing that we did with a resistor, with the diode in the AC, in the small signal analysis. Remember? Yeah. Remember? Okay. So we said that in AC, we don't use DC. But what is the information about the DC in? So it's in the resistance, and RD was equal to, the RD of the diode was equal to?
VT.
Very good, VT, which is the thermal voltage, divided by? Very good. That's where the DC voltage comes in. It's in the value of the resistor. Do you understand? That's why we don't use them. We use now the information that we have in DC, in the AC. So we are not throwing garbage like that. It's scientifically You know, study it, okay? Study the DC, then we take the parameters from DC, put it in the AC, and we study the AC. Because it's very hard to have two domains in the same brain. Clear? Got it? Very good. Excellent. All right, wait until you finish today's class because it will be full of math. Now, so this voltage now, V out, is equal to what? This V out. Because we are trying to find the relation between V out and V in. Is equal to what from this circuit? What's that? Raise your hand. Somebody. Somebody. Yes, Hiba? Try.
Equal the voltage in R0.
This is RD.
Yeah, equal the same voltage.
Hey, yes, this voltage is same like this one. Hey, and then
So
I want to find an equation for V out. This is what I want. La, why? Because I want to get the equation between V out and V in to get the gain. صح ولا لا?
V
That's what I want.
V over.
Yeah, V over.
We have RD. V over RD.
V over ID is equal to what?
R.
But I'm not looking for R. I'm looking for an expression for V out to get V in. Follow me here. Because this is maybe new, so you'll be lost for a while. I will tell you. Follow me, yeah? Who has an... go ahead. Yeah, this voltage is equal to this. Yeah, ما قلناش. بس where is V in? I need an expression for V out to get V in. Because I need to divide V out over V in. صح ولا لا? Understand? What's that?
To find the current. Then from the current and R can from V.
That's a nice one. But it's a little bit but it definitely will give you the answer. That's the way. But it's a little bit complicated, but I will show you a simpler way. But you are right. That's how you have to use Ohm's law, KCL, and KVL to find it. But that's the way. Thank you very much. It's very simple. You see that these resistors are in parallel. Yes or no? I can replace them with one. And that is this, parallel with this. Yes or no? Boom. That's it. I'm done. Not yet. Now the current, I have to clean. I become messy now. Huh? We know these things. Very good. And then you take this GM, blah, blah. Very good. Now follow me. Huh? Now the current is coming out of the resistor. Yes or no? Because this current is coming here.
Minus.
Very good. Thank you very much. So the out is going to be minus this current times these resistors in parallel. Yes or no?
Yes.
See, we are following your suggestion, but we are going a little bit faster. RD parallel with R0. Cool? Very good. Because this current also, I know that current how much is equal? GM VGS. Yes or no? So I can replace that. Clear? Very good. So write that minus GM VGS times this parallel, blah, blah. I know that. Excellent. So the next step is to find the relation between VGS and V in. What they are? They are equal. صح ولا لا? VGS is V in. Yes or no? Yes or no?
Yes.
VGS is V in or not? This is V in. Yes or no?
Yeah.
It's VGS because the source is zero. صح ولا لا? V in and VGS, they are the same. Yes or no? Clear ولا لا? صح ولا لا? The gate is where the terminal or the input voltage. صح ولا لا? That's where we are. Yeah. So V in is equal to VGS. So I just what to do? I just do this. So instead of VGS, I will do what?
VN.
V. سلامة سلامكم. And this parallel are not with R. And then from this equation, I will bring V in under V out. And then minus GM the R not in parallel will be the open circuit voltage. The open voltage, what is that? Yeah. So minus GM VGS, and that's the output. What is that? Just a second. Yeah. So here, so what do we say? What did we say again? So again, minus GM RD parallel with R0. Yes or no?
Yes.
So I can write this and bring GM, make it 1 over GM and صح ولا لا? It will be the same. Yes or no?
Yes.
Same or no? Math. We don't have to teach math
No,
again.
minus.
Okay, no, but minus is minus. It's there. We are not going to change minus. Yes or no?
Yes.
But this equation is nice because RD, R naught, they are actually the total resistance at the drain. Yes or no? Boom. From the drain I have these two in parallel. And the total resistance at the source, remember, in the T model. Let's go back to the T model. What is the T model? Where is the T model? The T model. Oh, no, this one. This one. Because this is related to... No. It's very hard. How can I go to T model? I think is the one. What's that? What is that? Oh, maybe, yeah, we used it later actually. Okay, let's try. That is actually, it's used somewhere else actually. Where is the T model? Oh, not this biasing. Okay, let me see T model. Did you see it here? No, not T model is not there. What's that? This is the T model. No, hold on a second. This is the T model here. You can see that the resistance from that is between the source and the circuit, the MOSFET, this resistance, we found it before, is actually 1 over Gm. So from the source outward, we have this 1 over Gm, and let's see, let's go back. I will include that in the slides, don't worry. So here, the total resistance at the the resistance at the source, we have that 1 over Gm. Okay? So basically this gain, you will see it again, so it basically is minus the resistance at the drain divided by the resistance at the source, which is 1 over Gm. We studied that in the T model. We don't have time to go back and revise that, but this is what we studied before. So this is the open circuit voltage gain. Now, the output resistance. We go back. So, to calculate the output resistance, what do? The first step that we need to do is to do what? The output resistance. We just studied it. صح ولا لا? We just define it. We have to do what? We have to ground what?
The source.
Yeah, this one. This one. Not the source. We have to ground the input voltage. The source is there. We don't care about the source. We ground the input voltage. So this has to go to ground. Yes or no? That means VGS now becomes what? 0. When VGS becomes 0, the current here is equal to what? The current becomes 0 because VGS is 0. So that means this branch is like open circuit. There's no current. Yeah, current is equal to 0. That's it. Boom. So if I send now IX, my current from the output, it will go through this and this in parallel, but it will not go there. It's open circuit, yes or no? So the output resistance is what? These two in parallel, yes or no? Make sense? Because if I divide this voltage by the current that I will send, I will find these two in parallel. That's it. I know that. صح ولا لا? Clear?
Yes.
And that's what we have here. And it's basically the resistance at the drain. That's what I have at the drain. At the drain, I have these two in parallel, yes or no? And that's what it is. Now, the last two parameters, they happen to be equal to each other. Why? We did not actually elaborate that last slide, but I have to go back and elaborate. No, not this one. I have problems today with the orientation. The overall voltage gain, I presented here a formula, but I did not explain it. Let me explain it now, okay? So I have to use this voltage. Good. So to find the voltage gain, the overall voltage gain, I have to divide this voltage by this voltage, yes or no? Very good. So I have to define the transfer of the voltage from the signal to the input, and from here to this voltage, and then from here or there, because it has to be open. Let's say because it has to be open, so there will be no voltage drop across this. So I'll just until here, and then the voltage from here to this voltage. So for the first one is basically, what I'm doing the following. GV, the overall voltage gain is equal to, so basically it's actually V out with RL, at RL, divided by the V signal. Yes or no?
Yes.
So what I will do, I will stretch. Let me take this out. I will stretch. How do I do stretch? I will make this 3 ratios. This ratio, this ratio, this ratio. That means V, so basically I will take this V out, divided, divided, divided. Okay? V out here, across RL, here. And at the end I have V signal. Okay? So what do I do next? I put here V in, and then here V in. Why? Because I want to cancel this. Nice people. Huh? And then I go here, V out, RL is equal to infinity, equal infinity, and divided by V out, RL is equal to infinity. So, because I can easily cancel them out too. Yes or no? Alright, so this is basically this transfer of voltage. See that the input here divided by the total voltage here is voltage divider, yes or no? This is a voltage divider, yes or no? This voltage from this point to this point. But this one is only from here to here. This is voltage divider or la? So I know this relation then in this case. So it will be R in divided by R6 plus R in, yes or no?
Yeah.
Yes or no? So this, then from here I go to this nice part. Yes or no? Excellent. Now this one, V out RL infinity divided by V in, it gives me what? It gives me this, AV naught, yes or no? Yes or no?
Yes.
Yeah, that's by definition. Now the last ratio here, V out at RL divided by, what's that? V out of RL, that means this voltage, divided by V out, V out RL divided by V out RL equal to infinity. That means the voltage in here, when RL is equal to infinity, that means there is no current. It means the current, the voltage here, without having any current. That means this voltage. And this is also voltage divider, yes or no? So this divided by this, the whole voltage, it gives me RL divided by R out plus RL, yes or no? And that is actually this last segment, yes or no? So the overall voltage gain will be this times that. Bingo. Clear? Clear or not?
Yes.
See the beauty of math? Play with math and a little bit of electrical, it'll be fun. Now we come to this. Now, remember here, our signal for our common source amplifier is so huge, it's infinity, yes or no? That means this divided by this, it becomes what? Becomes what? If Rn is so high compared to our signal, that means I can ignore this, yes or no?
1.
Thank you very much. So this will become 1 when Rn is so high or infinity, yes or no? Boom, this is going to be 1, so we can throw it away. So what remains is AV naught, RL divided by RL plus R naught. Is the same expression for the voltage gain, yes or no? It's the same. AV naught, AV naught. And by the way, the expression of finding V out over V in, the same way what we did there, is the same story. It's actually AV0, RL divided by RL plus R naught. It's the same thing. The same way that we find the overall voltage gain can be applied for the voltage gain. Boom. So that means when Rn is so high or equal to infinity, the overall voltage gain is the same as the voltage gain. That's the most important result. See, that's the result that we were talking about it now. Now, what we need to find is V out divided by V signal, which will be the same as the input. So it's going to be what? V out here divided by this voltage or this voltage, same thing. If I divide by this, I get the voltage gain. But if I divide by this, it's going to be the overall voltage gain. And we said that both voltages are the same. That's why the two gains are the same. So in that case, if I put RL at the output here, let's say I put RL and put it with black. If I put now RL, because that's the load, it's going to be like this. So that means between the drain where the output and the ground, which is the source in this case. So it will be between the drain and the source. So it will be where? Here. Yes or no? RL. And the story becomes very simple. Yes or no? Because in that case, I will have V out across the 3 resistors in parallel. Yes or no? So the same gain that we calculated before, all what I need to do is instead of RD parallel with R0, I will take RD, R0, and RL all parallel. Yes or no? Yes or no? And multiply by the current, which is J and VGS. VGS is Vn, and there is a minus there, divided by Vn. Same gain, same way that we calculated before. Same. And then Vn cancel, boom, boom. And I get what? The same equation. But here, it gives me the total resistance at the drain divided by the total resistance at the source, which is 1 over Gm. In the following amplifiers, you will see what I mean here by the total resistance at the source. But for now, we have only one, which is 1 over Gm. And then we finished with this characteristics of the common source amplifier. You feel dizzy, yeah? We have 2 more to go. But before that, we have another one actually. What if I put, okay, there's another way of analyzing this amplifier just by looking at the circuit without doing the conversion. Of course, this happens when you are what? Inshallah, experts. And you will be inshallah when you will come. Not really yet. So the experts, when they look at the circuit, which is the same like we studied just now, so what they do, they look at what's going on. They know that the current input is 0. So Rn is done deal, is infinity. There's nothing to calculate. Sah wala la?
Yes.
We'll tell you that's it. That's when you become an expert, you don't even calculate. Bye-bye. So now, we know that the current here at the drain is equal to Gm VGS. And VGS happens to be what? Same as the input. So from here, automatically I know the output is equal to what? Minus, because the current is getting out of the resistor, Gm V in. Now I know VGS is V in, yes or no? So boom, V out over V in, it's minus Gm, and then times the whatever resistance in here. Yes or no?
Yes.
So we get the voltage gain. And what else? When I ground the input here, that means VGS goes where? To 0. When I want to calculate the output resistance, so when I ground the input, that means VGS is equal to 0. That means there is no current going there. And the only resistance I can see here is this, parallel with this. Yes or no? Because there is no current in that case here. I is equal to 0 when I have this one equal to 0. Yes or no? Boom. We finished. In less than a minute. You can watch the video and see. I did the record. It's not me. Actually, you will be like that when you just be familiarized and revise well, and you find it really as simple as this. It's not really magic. Very, very simple. Okay? Let's move on. Very good. Now we make things spicy a little bit by putting an RS here. Remember when we put a resistance at the source terminal? Why we did it? We did it last, when? Yeah, actually last week. Exactly last week.
Negative feedback.
A negative feedback. Why? That's the technique. Thank you. 1 second. Give her a chance. Very good. To stabilize the bias point. Very good. Excellent. That's excellent. That's the whole point. Very good. Excellent. So we are going to study that amplifier. So same story from DC to AC, and then we get the final. Now instead of using the pi model here, we use the T model. Why did we call it the T model?
Looks like T.
Because it looks like T. That's it. Huh? There's no need to memorize. Huh? Looks like T. Huh? T. Boom. One leg, and in between there is a, and there is no current going in this, in the between. Huh? Very good. Very good, very good, very good, very good. Excellent. We get this. We are not going to repeat the steps. So simply, what's the input resistance? We said that the current here is equal to 0. Yes or no? The input is خلاص. Boom. Rn is equal to infinity. There's no magic about that. صح ولا لا?
Yes.
You're becoming expert by the end of the class, huh? Very simple. Just look, boom, that's it. So, now, the next one is the voltage gain, AV naught. Means that we don't have any load here, huh? Any load here. So, very good. This is actually even simpler. Look here. The input is this voltage, صح ولا لا? So it's going to be equal to the current that goes this way. Yes or no? Yes or no? Excellent. So let's write it. So Vin is going to be equal to that current. I don't know. I call it I. Who cares? Times these two resistance, 1 over Gm plus what? Rs. Yes or no? Then the current is coming into the resistor, not out of. فهمنا ولا لا? Excellent. Now what about the output voltage? The current is getting out of that resistor, yes or no? It's out. So V out must be minus that current times RD, yes or no? Notice that I did not put R naught. If I have to put R naught, it will be like this. It will be, again you have to revise between the drain and the source, yes or no? But I don't want to do it to simplify your life. Otherwise you will hate me. So to make it easy, let's take it out and then later on we'll consider it. We can do that, yes or no? If we ignore R naught, what we are ignoring?
DC.
No, not the DC. Oh, come on, we are not ignoring DC. We are ignoring something really important in MOSFET. When we ignore R naught, when we take it out, what we are doing? We are ignoring something in the MOSFET.
The length modulation.
Exactly, we are ignoring the channel length modulation. Remember? When we put R naught, there's a channel length modulation. When we don't include it, there's no channel length modulation. Lambda is equal to 0, and when lambda equal to 0, R naught goes to infinity. Yes or no? I can revision. It's not about magic. There's no magic here. Yes or no? But if you don't revise, you find this extremely difficult. I can assure you, I told you. صح ولا لا? I told you since the beginning. It's your call. Excellent, excellent, excellent. صح. So now V out is equal to minus, خلاص. I gave you the answer, yes or no? We divide this nice guy over this nice guy. This I will cancel this guy, and we have minus RD over these two. What is that? Boom. صح ولا لا? Magic? No magic. Simple. Clear? Clear or not?
Yes.
خلاص. We'll finish this one. You see here, that's what I said here now. How much resistance I have at the drain? I have only this RD, yes or no? And how many I have in the source? I have this and this. Because they are in series, so I have to add them. So at the source I have this 1 over Gm plus Rs, and that's P. So you see that the voltage gain, I can just express it by a ratio of two resistances. See? Excellent. Very good. Now, in the output resistance, what do I have? What do I have to find the R out, the first step? Ground, yeah? Yeah, what's the, the input voltage? Very good. So we have to ground this guy. So we have to put a connection to the ground, yes or no? Very good. When I connect here to the ground, what happens? That means when I connect to the ground, okay, when I connect to the ground, so this is ground, this is ground. The current in here, is there any current at all? There will be no current. First of all, because I know this current is dependent on VGS, yes or no? So, when I connect this to the ground, I will make, exactly, so I make VGS is equal to 0 in this case, yes or no? And if I make this VGS equal to 0, this current automatically goes to 0. Boom. And if I make this current, I have open circuit, yes or no? So if I now inject IX this way, so my current will come here, boom, boom, and goes there or no?
No.
It goes only through RD, boom. So that's the output resistance. And it happens that that output resistance is actually the resistance at the drain. That's the only resistance I have there, yes or no? That's it. So R out happens to be. And why I show you this? Because when you see the similarities, you will see that They are pretty much the same. Okay, very good. Now we come to the voltage gain and the overall voltage gain. You see? They are the same. Why?
Because the Rn goes to infinity.
Exactly. That's it. So I don't have to calculate both of them. Huh? See? If you know what you're doing, you save your time, you finish quiz or exam, and then you go home. Because you know what you're doing. But if you don't revise, you will not be able to know what you're doing. And you will suffer calculating this, and you can suffer to calculate that. And good luck to you, and then the grade will be horrible. Now, because Rn, and this is the symbol of the because, when you have 2 points and something in between, because it becomes because Rn is equal to infinity. In that case, the voltage gain, again, the same way that we studied before, the same way, exactly the same thing, are actually the same like this one. So in that case, I have in this case what? I have RL in here, yes or no? Because here, the voltage gain, I have to have RL. Yes or no? This one, I should not have RL, or RL is equal to infinity, same story. So here I have RL. So the only thing that has changed is that instead of RD, I have these two in parallel. Yes or no? Boom. We don't have to spend much time. صح ولا لا? In 2 minutes, we finish. That's why. But I have to explain. That's why it took time. But later on, it will be like it. Very good. You can see also, again here, the same story, although there is a minus. It's actually the total resistance at the drain, RL parallel RD, divided by the total resistance at the source. Same exact observation that we had before. Okay? So the voltage gain, now we can express it just as a ratio of resistances. This is the beauty of electrical engineering. And we finish today's class with this storm. The storm is about the common gate amplifier. It's extremely simple. So this is the circuit. In DC, we have to change it to
AC.
the AC. And again here, we use the pi model, but we could use also the T model, whichever is easy for us. And again, we took away R0. You can include R0 as well later on, but don't worry. Now the input signal is coming into the source, go out from the drain. That's it. So this is the input, and the output is from the drain. That's it. Rn, is it infinity now? No, Rn is not infinity. Yes or no? Rn has a value.
1 over G.
Yeah, it's actually 1 over Gm. That's, if you take actually the T model, you will find that the resistance from the source looking into the MOSFET is actually 1 over Gm. But if you want to find it, it's very simple. It's very simple. Now, let me show you this. So you can see here that or Ohm's law actually, if you want. Okay. First of all, before we're going anywhere else, you can see that V input here and VGS, they have a relation between them. VGS, which is 0 minus VS, and the input is actually VS minus 0. So they have a minus between them. Yes or no? This is number 1. So I know VGS is equal to minus VM. And okay. So the current in here is equal to what? I is equal to the current. I know the current that comes in is actually opposite to this. Yes or no? It's actually minus GM VGS. Yes or no? This is the first thing.
Yes.
And VGS is actually minus the input. So minus becomes plus. Yes or no?
Yes.
So it becomes GM V in. Yes or no?
Yes.
That's it. V over I is equal to 1 over GM. And that's what it is in here. Yes or no? Remember GM in the last couple of classes? When we compare BGT to MOSFET, is equal to roughly how much? Between 0.35 and 3.5. Remember? When you have the W over L is equal to 100, and we use GM equation. Remember that? Revision would be helpful as well. So typically is actually in the range of milliamp per volt. Between 0.3 and 3. Let's give it 1. Because 3.5 happens to be at W over L is equal to 100. There is no resistor 100. W over L. So let's give it 1 milliamp over volt, GM. 1 over GM will be volt over 1 milliamp. It means how much resistance? 1 kilo. So from infinity to 1 kilo. This is very small. 1 kilo ohm is a joke. صح ولا لا? Even in the lab, you throw this 1 kilo ohm. You don't even calculate it. Now the rest, AV naught, the same thing, is actually V out over V in, but there is no RL. Very simple. You can make it like V out over the input current times the input current over V in. We know this relation, yes or no? This is 1 over GM, yes or no? And V out over input, the input current that we send here is the current that goes in there, yes or no? That's it. So you will find that is going to be RD over 1 over GM. That means the drain resistance divided by the source resistance. This is equal to GM/RD, and that's it. All right. Now, there's a typo here. There's actually AV. Now, for AV here, the difference is that we have RL, yes or no? So here, at RL, I'm calculating here the voltage gain. So in here, the only change that I will do is RD will become what? In parallel with RL, yes or no? Because RL is between the drain and the ground. It's here. Where is the RL? It's going to be here, yes or no? This is where I need to put the load. Huh? Yes or no? So it becomes in parallel with RD. That's it. So instead of RD, I will take RD parallel with RL, and then boom, the same story. And then we get basically RD, RL, the parallel over 1 over GM, يعني the drain voltage over the source, the drain resistance, sorry, over the source resistance. Boom. Here also there's a typo, it's actually parallel with RL. Okay, I will fix that in the slides, don't worry. Now, for the input, output resistance, when you send a current in here, you have to ground this guy. So that means now the source is going to become what? Exactly 0. So VGS, it becomes 0. So the input is 0. So the input voltage 0 makes VGS is equal to 0. The current is going to be equal to 0, and then boom. And the output resistance is going to be the two in parallel. Yes or no? RD, I have to change also here. RD parallel with RL. And then there's a mistake there, okay? So RD parallel with RL. It's not a big deal, I will fix that because I quickly finish these things. Now the overall voltage gain, now we have to include everything, yes or no? So it has to be R signal, Rn divided by Rn plus R signal, yes or no? Which is this ratio, yes or no? Times AV naught, let's see here. Ooh. If you want, or you can make it that the same equation that we studied before, or you put V in between, and this is basically V output including Rn divided by V signal. V input over V signal, which is the voltage divider that we said, the input resistance divided by input resistance plus R signal, which is that gain there, times the overall voltage gain, the voltage gain including RL, which is this voltage gain, GM/RD parallel with RL, okay? And that's it. When you multiply GM in here, it will cancel out, and we will have these parallel divided by these two. And this is basically the total resistance at the drain divided by here, the total resistance at the source. And see you next class. We finished exactly at that time. Okay, we take attendance now, and that's it.